In machine learning, we love to focus on architectures. But recently, I've been intrigued by the tiny and elegant ideas we often forget about. One of the most beautiful examples of these is the Dropout paper. The primary goal of Dropout is to prevent overfitting. If we draw a loss graph with steps on the x-axis and loss on the y-axis, overfitting is when the training loss keeps decreasing, but the validation loss doesn't. This means the model is learning the training data too well, instead of learning the overall pattern. Dropout solves this by, as its name suggests, randomly dropping units out of the network. Consider a fully connected multi-layer perceptron with one hidden layer. Let's remove all of the connections and assign a probability p that any one of those neurons will be removed. With two neurons randomly removed, we can redraw the connections of the network and observe how connections leading to and from dropped out units are no longer present. Each forward pass, we can repeat this process, giving a different combination of remaining units each time. At test time, we can weight each connection with the probability p to simulate the effect our training had on the network. The effect of dropout is that coadaptation is reduced. The authors use a really interesting analogy of a conspiracy to explain this. Imagine the units of your network work at a very large bank. If all the bank tellers or units of your network are all in on a large conspiracy to steal all the money from the bank, they can each take an individual role to make this happen. In other words, overfitting. However, if we randomly remove bank tellers, we can foil this conspiracy and hence prevent overfitting. The authors run some experiments to show how dropout improves supervised learning. With dropout, the classification error on a supervised task is lower than without. If you found this video helpful, consider liking and subscribing, as I'll be producing more videos like these on other ML topics. Till I see you next, don't forget, papers are wonderful.